This is continuing with our sine function, y equals sine x. So our goal today is I can apply the transformations of vertical displacement, okay, so I'm moving the graph up or down, and amplitude changes to the sinusoidal functions. Okay, so first of all, this is just that graph that we worked on yesterday. And we notice that the lowest, highest, and middle points occur every 90 degrees. So 0, 90, 180, 270, 360, keeps on going and going and going. Okay? Make sure that you have memorized 0, 90, 180, 270, 360. Very important. Also very important, make sure that you memorize that sine starts in the middle of the graph, okay, and usually goes up. We're going to look at an example where it goes down, but for the most part starts at the middle of the graph and goes up. All right, so vertical displacement. Vertical displacement, the equation is going to look something like this. Y equals sine x plus or minus a number. Okay, so that's where our displacement is. It's not so important that they use the letter D for displacement, it's where it's located. So you have your function and then it's plus d. So it's like moving, in a sense, a parabola where you actually move a parabola up or down based on, y equals x squared. When we had y equals x squared, and then we did plus 4. It meant that I would move the whole graph up 4 units. Okay, so the D moves the middle of the graph. So the middle of the graph gets moved. So the x-axis is no longer the middle of the graph. Okay? The middle of the graph will be the value of D, and we call it, depending, the baseline, reference line. It depends on who you're talking to. Okay? So it's the middle of the graph is what this number creates. Okay? The important x values do not change. Okay, so that means that 0, 90, 180, 270, 360 does not change. All it means is the graph is just moved up or it's all been moved down. So let's take a look at how we would do this. Okay, so on the next page. Okay, so here is y equals sine x minus 1. Now the reason I have numbers here is tells me where I'm looking first and what I do. So you can see I have x and y labeled. Okay, and I probably should also have labeled a few numbers. So here's 1, here's 2, here's -1 and -2. And we already know that all we've done is this, so we just need to put 0, 90, 180, 270, 360, and we can keep on going. You would have to show at least one period. So if we added 90 again, so we're at 450. Another would be at 540. 630. Okay, so we just keep on going and going by adding 90 each time. All right, so the first thing we would do is we would look at, I should change that so it's not quite that thick, is number 1. So we look at the end of the equation, and for number 1, it means that, as soon as I find it, it's located here, I know it is. We draw a dotted line at -1. Okay, so that's down here. So that means the middle of the graph now is going to be at -1. So the easiest way to do that, and we'll do it in purple so it matches, and we're doing a dotted line at -1. That's the middle of our graph. The next thing that we do is we look to see what's in front of sine. Here, the number that's in front of sine obviously is 1 because there's nothing that I can see there. So it means that I'm going to go up 1 and down 1 from that middle, that reference line or that baseline. So this time I am going to put a dotted line on the x-axis. And I'm off a tiny bit there, so I'll just bring it up a bit. Okay. So now all I do is I treat it like a ping pong ball. We know that sine starts, the third thing I look at, sine starts in the middle. Because it starts in the middle of my graph here is going to be at 0, -1, and then I go up. Every time I cross a dotted line and one of those special x values, I put a ping pong ball. And it just keeps on ping ponging. It has to fit in between there. Okay, so now I have all my points. All I need to do is create a smooth curve. And here is our nice smooth, oh, that one's pretty well off. Okay, it's not a pointy graph. It's a nice smooth curve. And I said I was going to put arrows, but I'm going to put my line up a little bit because I know I can't go below that dotted line. Okay, and so there's the graph. It's that simple. Okay, so all this does is change where the middle of the graph goes. The next thing that we're going to be looking at is amplitude. So amplitude has to do with the number in front of our function, and here it's a, so they have it as a. So the amplitude of y equals sine x is 1. We just did that. When we multiply these values by a number, a, whatever number is there, it changes the amplitude. Again, the important x values do not change. The graph is just taller or shorter. So again, same kind of idea is we are going to look at the end. You can see there's nothing there, so I don't need to put a dotted line. I need to put a few numbers here again, so I'm just going to pause and put that. You don't need to watch me do that. Okay, so I have my important x values written down, and I've given some labels to the y-axis. As I said, nothing's happened here, nothing's been added or subtracted, so that means that my x-axis is the middle of the graph. The next thing I look at is the number in front here. The number in front is a 3. So that means I'm going to go up 3 from that middle and down 3 from that middle and put a dotted line. So we will do it in red only because my number 2 is in red. Okay, so up 3, down 3. My graph has to fit in between here, so it's just like that ping pong ball. Okay, sine starts in the middle. And starts in the middle and it ping pongs up, back down, down, back up, back down. Okay, so that's all it is. Again, a smooth curve to join everything nicely together. Okay, and I'm sure your smooth curve will be much smoother than mine. Okay, so our amplitude now is 3. Everything else has stayed the same. Now let's look at putting all of these items together. All right, so when I have an amplitude change and a vertical displacement. Now, are there other transformations? Yes, the next video talks about a phase shift, and that's moving the graph left or right. Okay, so the first thing that I would do is I draw a dotted line at the baseline, in other words, the vertical displacement. So that's that D. So if you want to put the letter D there, you can do that. I'll just do that for us. Okay, so that's that D value. Unless it's the x-axis, and normally we don't do it for that. Then we draw dotted lines from the baseline as many units as the amplitude. Okay. Then sine starts at the baseline and usually goes up. And the points act like a ping pong ball. Every time the ball intersects with the dotted line and the important x values, we add a point. Finally, we join the points with a smooth curve. It's that simple. Okay, so let's do some examples together. So here it's asking us graph the following and then state the domain and range, amplitude, and vertical displacement. All right, so again, we know that the important x values do not change, so I'm going to pause it again and put them here so you don't have to sit there and watch me. Okay, so I've went to 540. It is quite a challenge just doing it with the mouse. All right, so I look at the end first, and it says -1. So I know that I need to put a dotted line at -1. And again, it doesn't matter what color you use. I just was having fun. So -1, I have a dotted line. So this is my middle of my graph. Then I look to see what's in front of the sine function, and it's the number 2. So from that middle of the graph, I go up 2 units, so my top number is +1. I go down 2 units, my bottom number is -3. Okay, so my graph is going to ping pong ball between there. Okay, sine starts in the middle and usually goes up. So that's what we're going to do. So it starts in the middle and ping pongs up. Back down, up, down. And we could keep on going and going and going. Okay, so, and notice I also had a -1 here, so I'll just put that there. Okay, so that's the pattern that it follows. Again, a nice smooth curve as best we can. And we are finished with the graph portion of the question. And that last part looks like awful. And you're saying, yes, I agree, it does. Okay, and so I have my arrows on both ends. Okay, now let's finish answering the question. It says state the domain and range, amplitude, and vertical displacement. Okay, so first of all, when I'm looking at my domain, x again can be any real number. You can put yours maybe below if you have room for that. So that's my domain. My range, y also is any real number such that, okay, and this is where our ping pong fits in. So it fits in between two numbers. The smallest number it can be is -3, and the highest number that it can be is +1. Okay, our amplitude, A equals 2, and our vertical displacement is, and we're going to put it down 1. Make sure you put the word down 1. Okay, so it's that simple. And let's go take a look at some more. What I'm going to do is we have 2 more examples to do. I'm going to pause the video and put those 2 examples on the next one.